morning, good afternoon, good evening, whatever time you're watching this. This is the notes for, or these are the notes for March 23rd, 2026. We are going over solving quadratics by graphing some more. Remember that the solution to a quadratic equation is always the x-intercept, so we're going to keep rocks in mind because they're going to ask several different names, and they will use all four of these interchangeably on the STAR test and on your unit tests in class and questions even on Excel. So rocks is roots, zeros, this is a z, x-intercepts, and solutions. So that's what we need to keep in mind when we're solving, or where it says solve or find the solution, or what is the zero, or what is the root, or what is the x-intercept to this quadratic, and even linear. It will say that for linear as well. Linear is a straight line, but this is the quadratic. Remember, these are parabolas that open up, that's positive, and down, that's a negative. So it says sketch a parabola that has the following. So two real solutions, that means two real numbers are visibly there, and it'll cross the x-intercept or the x-axis twice. Once, twice. One real solution is where it only has one x-intercept. Typically that's where they put like the vertex over here or over here. So these only have one x-intercept. This one looks a little flicked. No real solutions means that this is floating in a quadrant. It is not ever going to touch the x-axis. Okay? These are not real solutions. You might have seen something like this on the interim test. So first we must write the equation in standard form. That's y equals ax squared plus bx plus c. Graph the function in Desmos, and then identify the x-intercepts. Always use the letter x in Desmos, okay? So for this one, and then we need to solve for 0 when needed. So for example, this one is one where I would have to solve for 0 because it doesn't have a 0 here. I have to visibly see the 0. But remember, this part does not get typed into Desmos. I saw some of you guys trying to do that last week. That's not what we're doing, okay? So let's go to Desmos and start typing these in. So the first one says x squared minus 2x minus 8. Now remember, if it says something like z squared minus 2z minus 8, remember to change those z's to x's when you type them in. So x squared minus 2x minus 8. Now look and see where they cross the x-axis. That's negative 2 and 4. So x equals negative 2 and 4. So negative 2 and 4. And then what's my vertex so I can plot that? 1, negative 9. Oh, it's not going to go. It's not going to be visible here. And 0, negative 8. Okay, this isn't going to go down that far. I've got to kind of sketch it because it's below. But these are what's important, y'all. Okay? When it's asking for solutions. I also saw a lot of us clicking on this y-intercept here. We have to distinguish and read what they are asking of us. Are they asking us to look for the y-intercept? Typically, that's going to be like a very wordy problem, like which of the following statements is true? The y-intercept, the minimum, the maximum, the vertex. But when they ask for solutions, this is what they want here on your graph. Okay, so this one over here, we need to solve for 0. So this says -9. I need to add 9 to both sides. I want everything to be on one side, just like it is here. Do you see how all of my terms are over here, and there's a 0 over here because I'm looking for the 0. 0 is the important number, not -9. If I type this in a Desmos, Desmos is going to be like, what you talking about, girl? Like, what are you trying to do? So here I need to add 9 to both sides. This will not be 3x. I have to have 3 terms for the most part. Sometimes I'll have 2 when it's a difference of squares. Now I need to type this into Desmos. X squared minus 6x plus 9. Minus 6x plus 9. There's only one solution here, and it is 3. X equals 3. Now if I want to graph it, I can look at some other points here, like clicking on the gear and then going to the table. Let's see, 3, so 2, 1, and 4, 1. 0, 3, 2, 1, 4, 1. Are there any 5s on that graph? 1, 4. Go back. Run 1, jump 4. So then it's going to be the same mirror image over here. Run 5, jump 4. Graph. And graph. And again, my solutions are on the x-axis. Just one solution here. 2 over here. -2, 4, and 3. Over here, p squared minus 3p plus 5. Go to Desmos. P squared. P is not going to work. I must use x. X squared minus 3x plus 5. Boom, bam. Oh, I don't need the vertex. 0, 5 is a 0. There are no real x-intercepts here. There are no real solutions. No real solutions. So 0, 5, and let's look at some other points. 3, 5. So if I were to graph this floating guy, 0, 5, and 3, 5, and then what was my vertex? It was a decimal, so I'm going to have to approximate. Oh, we got to get rid of the points. There it goes, 1.5 and 2 3/4. So 1.5 and about 2 3/4 right here. Boom, bam. Okay, now it says you try. So remember, I've got to get this p squared plus 25 equals 10p. I've got to subtract 10p from both sides. This becomes p squared minus 10p plus 25. Got to find the zeros there. Here, I got to move this x squared over here. Actually, no I don't. I've got to add both of these to the other side. X squared equals -8x minus 16. Add 8x, add 16. X squared plus 8x plus 16 equals 0. Cancel that out. X squared plus 8x plus 16 equals 0. This also equals 0. And then here I'm just moving the 6x to the other side. Minus 6x minus 6x. This becomes -2x squared minus 6x minus 8. So these 1, 2, 3 all need to be graphed. Let's put those on the back. Oh, just kidding. Okay, where is my